This module covers artifacts being present in the file system itself, because file system can provide a lot of interesting metadata about your things. So the very well known, it is something we can observe here within the metadata. We can have created, modified and accessed information for every single file and folder. Please be aware that access does not necessarily has to be up to date, because sometimes it's being turned off for performance reasons. No thanks. And we can also verify those from the PowerShell. cd desktop, and here if I do dir, let's take fdij, select everything, all metadata of a file are being displayed, so you can see creation time, last access time, last write time, both in the local time and in the UTC. I'm 1 hour ahead of UTC, so local time and UTC differs by 1 hour. And here one of the things which is important when it comes to this 3 times is those times are fully writable by anyone having a permission to it. So I can do simply dir access this particular property. Let's take let's take creation time, because it is the date and time when the file was created, and make it equal get date. I will add minus 100 days into it. And right now, if you check, does not matter if you use PowerShell or if you use created, why it because I picked the wrong one, it should be this one. So right now it was creation time was 3/16, and now you can see it is 7th of December. It is 100 days from the current time. So you can use obviously this data. For example, within some forensic scenario, if you know the time frame for an attack, for something malicious happening on the machine, it's happened today between 10 and 12, you can easily filter out all files on the drive which appeared on the drive between 10 and 12, and you have kind of additional information about the attack. But a smart attacker, and it happens within the real attacks, smart attacker can change those, can manipulate the date and time of the file to make file happening on the file system in totally different date and time. So we have a useful artifact. In the same time, it is not 100% reliable, which also has its own values, because if we can prove such unreliability, in most cases it means something as well. Another artifact we had within the Windows NTFS file system is journal. Journal is just a log registering all changes within the file system. I can verify if I have a journal. By default I have, using fsutil command, and usn subcommands are related to the usn journal. I can create one if I do not have it. I can remove journal if I want to wipe traces. Admin permissions are obviously required. I can query journal asking what is all about, and I can read data from the journal. So right now I want to query journal, and obviously I have to specify a drive. It is about the C drive. So here I can see information about the journal itself. I can display the data from the journal using read journal. As I have said, journal is registering all changes on the file system, so it is long. So you can see it has a lot of, if I do query journal, I can see what is the first entry in the journal, what is the last one. Those are not one by one, but at the same time we have up to 32 megs of data of the history. Interesting information within journal is about the file name, but we have no path. We have a parent file ID, which is a ID of the parent folder. So we have no name of the parent folder, we have only ID of the parent folder, we have to find it on our own. It is doable with fsutil file if you want to do this on your own, fsutil file, and then there is a query, query file name by ID, this one. This one allows you to provide ID and it returns the name of the folder you had. And we have also information why some particular entry appeared in the journal, what changed on the file system, making journal entry appearing. So like basic info change, or file create for creation of the file, etc., etc. There is always a reason for the change. You have to know what it means, but it's a matter of practice. You will quickly realize what is going on. When it comes to USN read journal, it had read journal, I will specify it this way. You can export it to CSV, but I do not like it because importing journal into Excel is very helpful because you can analyze a lot of things, but the CSV format is somehow messed. For example, if you have US date format, it will be US, etc. So it may be messy sometimes. I have written my own version of this. It is on my GitHub within a special folder focusing on the journal only. I'm converting it to a real CSV file, not the Microsoft CSV file. Another things related to the journal I have here are quite interesting. The first one is check USN monotonicity, because every single journal entry, if I take a journal entry, this is one of those, has a timestamp. And there is no way of manipulating the timestamp, of creating an entry within a journal, not actually reflecting the time we had on the system clock. So if someone manipulates a clock, because the data on the drive is changed nearly constantly, it is most likely that during the time manipulation, some entries will appear before the manipulation, after the first manipulation was made, and after the second manipulation was made on the clock. It is very likely. So if I find a fact that a new journal entry, the newer one, because here comes one of those, here comes the previous one, here comes another one, and so on. If I find a next entry, but with the earlier date and time, probably something happened with the clock in the meantime, because it should not be earlier. And I have created a tool, it is check USN monotonicity. Check USN monotonicity, and this one is also interesting, at least for me, because it does not require admin rights, because admin rights are required to read a file name. File name is considered kind of sensitive information. So you can read a journal if you do not ask for the file names. But for our verification of date and time, it should be perfectly enough if we can do this even without name of the file, because this is not that important. So check USN monotonicity, and here you can see it is analyzing C by default. You can specify another drive. I'm sharing the source of it on my GitHub. You have the information, so you can see the oldest thing in the journal is like this, the freshest is like that. So it covers a couple of days as the Windows was freshly installed. In this time we have 200,000 entries and no inconsistencies found in the meantime. If you manipulate the system clock, most likely you will observe some entries, because you can FSU till USN do a read journal from C wait tail. It is an interesting feature because it displays changes, I would say, live. So I do anything, for example, I launch it again, and a couple of writes appeared here. .pf files for FSUtil, .pf file for the for my tool. If you look into the prefetch module, you will realize what is .pf file. I have explained it within this course as well. So even launching a simple file leaves some traces on the drive, and obviously the time should only increase within the log. Another tool, I'm also sharing the source, is FDIJ. This one requires administrative permissions because this one is reaching for names. FDIJ is about finding some deletions within journal. I will copy as path and I will paste it over here, because of course deleting a file leaves a trace within journal, which makes perfect sense. And I'm trying to analyze a journal in a way not only allowing you to spot something was deleted, but also trying to figure out which folder it was a child from the file system perspective, even if the folder was deleted as well, because folder deletion, not the big surprise, leaves a trace in the journal. So the analysis must be done this way. This is the syntax for the volume, and now it goes through all entries and trying to display everything I can identify as a deletion on the file system. As you can see in the live system, there is a lot of deletions. The format is not nicest because it's too wide, but at the same time you can clearly see information about every single deleted file. Those with a quotation mark here in the name are related to the guest folder name. I should actually run it by piping it into C users GT desktop FDIJ txt, and now it should be way nicer to be observed, analyzed, and so on, because here I have some header, but after header, if I have no word wrap, I can simply go an entry, one entry after another one, trying to figure out what is going on. You can also import it to Excel, so you have a timestamp where when the deletion happened. If I go to the very end, I can see deletions happening lastly during last couple of minutes. So you can see some files are appearing on the drive and then being deleted from the drive. You can see the history from this perspective as well, just by analyzing the journal. So wrapping everything up, we have two interesting forensic artifacts within the file system. We have date and time of every single file system object. Please do remember this one may be manipulated. Every of those three can be manipulated. And I want to tell you that if date and time may be manipulated, you do not have to trust it. However, verifying it makes sense. And we have a journal which can be overwritten by changing a lot on the disk, which can be deleted if you have admin rights, which will leave some traces, obviously. But if the journal is present on the drive, it contains somehow limited but extremely valuable forensic information, telling you entire story what happened on the drive during last couple of days at least.